Hi, today we will derive a lens formula. We know that when an object is placed before any lens, the lens forms real or virtual image at certain distance. And a relationship between object distance and this image distance and focal length of the lens. This relationship is called lens formula. And here you can see in diagram 1 by V minus 1 by U is equal to 1 by F. This is your lens formula that I am going to derive using a convex lens. So firstly I'll discuss a ray diagram of the image formation through a convex lens. And then we will use geometrical concept, the similarity of triangle for deriving relationship between object distance, image distance and focal length. So here I have taken an object is AB and I have used two helping rays. What are these helping rays? We know that image can be formed using Snell's law. That is mu1 sin I is equal to mu2 sin R, but that is a lengthy process. We need to do all the geometry, all the trigonometry, and then we can find image distance. Then we can find image height. And a simple way is to use three helping rays. We have three helping rays. We know that after refraction through the lenses, where these three helping rays will be converging or diverging. Like a parallel ray will always converge through a point that is called focus. Similarly, you have a point that is called optical center. If any ray passes through optical center, it passes undeviated. It passes along a straight line. So these helping ray will help us draw the diagram of image formation, image distance and all other things. So here you have meeting point of the two rays. They are meeting at this point, and meeting point of any two refracted ray gives you image. Here image is formed of the object AB and the image is your A dash B dash. Now we will be using geometry, all other concepts to find relationship between U, V and focal length F. So this is your focal length. Here distance from optical center up to B, this is your U, and distance from optical center to B dash, this is your V. Now before doing the geometry, before measuring the length, we need certain rules that are called Cartesian sign convention rules. Because for measurement we need to take negative sign or positive sign. So first of all let us see what are these Cartesian sign conventions. So first one is that all the distances are measured from optical center itself. If you have to measure object distance, you will be measuring from optical center. If you are to measure image distance, you will be measuring the distance from optical center only. So this is your first Cartesian sign convention rule. All the distances are measured from optical center. And now second one, the distance which is measured in a direction opposite to the direction of incident ray, that should be taken as negative. And all the distances which are measured in the direction of incident ray, that should be taken as positive. Now every height above principal axis is measured with positive sign and all the distances below principal axis is measured with a negative sign. So now we will be using these Cartesian sign conventions and we will be deriving the lens formula. So first step while deriving lens formula, to find similarity among pair of triangles, you have two pair of triangles, you can see, that are similar. Here OAB, there is a triangle, and OA dash B dash, there is another triangle. You can see the two angle of these two triangle are equal. Like this, your vertically opposite angle are equal, and here you have right angle at point B and at B dash. So two angles you can see, you can find that they are equal. So the triangles are similar. Step 1, to find similarities among the triangles. So in triangles ABO and triangle A dash B dash O, we have angle O is equal to angle O. Vertically opposite angles are same. And you will find that angle made at B is equal to angle made at B dash, that is equal to 90 degree. Therefore, since the two angles are same, therefore triangle ABO is similar to triangle A dash B dash O. Here I should write that since two angles of the corresponding triangle, two corresponding angles. Okay, let me write on this side. Here I have not space for writing this thing. Here two corresponding angles are equal. Therefore, the triangles are similar. You have similar triangles. And in similar triangles, ratio of corresponding sides is same. Like in these two triangles, you can see what are the corresponding sides. Let me show you. Here you have height AB, and corresponding side in this triangle O A dash B dash is height only, A dash B dash. So ratio of the two, AB divided by A dash B dash, must be equal to ratio of the bases, OB divided by OB dash. And we will not consider the ratio of this hypotenuse, though the ratio of hypotenuse also is same, but they are of little use here because it is neither your object distance nor the height of the object. So we will find similarity. Therefore, in the triangles, you can say that AB upon A dash B dash is equal to the base of ABO triangle is OB upon the base of O A dash B dash triangle is OB dash. So here you get equation number 1. Similarly, in triangles, you have one more pair of triangles which are similar. So in all these kind of derivations, your first step is to find similarity among pair of triangles. Now in these triangles POF2 and F2B dash A dash, you can see that vertically opposite angles are same, and this angle is 90 degree at O, and also at B dash you have angle 90 degree. So in triangle OPF2 and triangle F2B dash A dash, you find that ratio of sides. So here OP, which are the two sides OP and AB of parallel lines. So OP should be written as AB also. OP is equal to AB. So we will find ratio of OP, that is AB divided by A dash B dash in these two triangles. AB divided by A dash B dash is equal to, now bases of this first triangle, OF2 divided by F2B dash. So in the two equations you can see the left hand side of the two equations are equal. Therefore, comparing equation 1 and 2, now on comparing equation 1 and 2, you get OB divided by O dash B dash OB dash is equal to OF2 divided by F2B dash. So our first work is over. We have compared the triangles using similarity concept, similarity of triangle. Now step 2, to use sign convention. And we will change OB, O dash, B dash, etc. into object distance, image distance, U and V by using proper sign convention. So here, OB is object distance, and you can see that this OB is measured in a direction started from O up to B in a direction opposite to the direction of incident ray. So this U should be taken as negative. So here OB is equal to minus U. Similarly, OB dash, it is measured in the direction of incident ray, so and it is image distance. So it should be taken plus V. OF2, in a convex lens, focal length is positive and it is on the right hand side from optical center. So you should take it as plus F. Now F2B dash. So up to here you could see that all the distances are measured from optical center only, but this distance is not from optical center. So I'll be changing this distance from in terms of your optical center. So OB dash minus OF2. Here you can find that in this diagram F2B dash. How you could find this F2B dash? This will be equal to OB dash minus OF2. So I have taken OB dash minus OF2, and this is equal to your image distance. This is your positive on the right hand side from optical center, and this is your focal length. This also is positive. So F2B dash comes equal to V minus F. Now we did two things. We used similarity of triangle. This is your first step, and now we use sign convention, and we will put value of all these things in equation A. So putting these values in equation A, we get that OB by OB dash. Okay, this is your OB by OB dash, means minus U upon V is equal to OF2 by F2B dash. What is OF2? OF2 is your plus F, and F2B dash is your V minus F. Now we will do simplification of it by changing the sides by cross multiplication. Minus UV minus minus plus UF is equal to VF. And the last step is to divide the two sides of equation by UVF. So on dividing the two sides of the equation by UVF, what we get? This is your minus UV upon UVF plus UF upon UVF, and this is equal to VF divided by UVF. So let me simplify all these things. U cancel, F cancel, VF cancel, VF cancel. So we come to our lens formula. Here 1 by V, and I am changing the side of this term, will be equal to minus 1 by U, and by taking 1 by F minus 1 by F on the other side, we get it is equal to 1 by F. This is your lens formula. Now we will find magnification of image. When image is formed, it may be formed smaller than object or it may be formed larger than object. So the integer number of times by which the size of image is changed with respect to object is called magnification. And magnification is given by image height up to object height. So we will be using again the ray diagram and we will be using the concept of similarity of triangle. By the similarity of the triangles. Which triangle? A, B, O and triangle A dash, B dash, O. So ratio of height should be equal to ratio of bases since the similar triangles in similar triangle. Okay, so your A dash, B dash, I have taken height of this image. So this divided by height of object, this must be equal to image distance, this distance, O B dash divided by object distance OB. So first step was to use similarity of triangle, and now second step, step 2, to use sign convention. And you know that A dash, B dash, it is equal to image height, and this has formed below the principal axis. This would be minus H dash. Image height is taken as H dash, and object height, object is forming above principal axis, so this should be taken as plus H. Similarly, you have OB dash, image distance. This is on the right hand side of optical center. You should take it as positive. And OB, that is your object distance, this is your negative. So for magnification, we need to find H dash by H. So let me put all these value in this equation number 1 or I. So in equation I, you have A dash, B dash by AB. What is A dash, B dash? A dash, B dash is minus H dash upon AB is H, is equal to OB dash, it is plus V, and divided by OB, that is minus, this is your minus U. Minus U. So from here you get H dash upon H is equal to minus V upon minus U. Minus minus cancel and this becomes equal to V upon U. So this is your magnification of image. Now you can change the form of this magnification of image in terms of object distance and focal length of the convex lens. So firstly we will change the numerator and denominator. I am inverting magnification. So 1 by magnification is equal to U upon V. And now we will be putting value of 1 upon V using your mirror formula, lens formula. Since in lens formula, 1 upon V, this quantity, 1 upon V minus 1 upon U is equal to 1 upon F. Therefore, 1 upon V is equal to 1 upon F plus 1 upon U. And this is equal to, I am taking LCM, UF, LCM, and here it comes U plus F. So now let us put the value of all these things in this equation. So now in equation 2, Arabic letter 2, you find that 1 by m is equal to U and into 1 by v. What is 1 by v? U plus f divided by uf. U and u are cancelled, and therefore again when you invert this 1 by m, you get m. M is equal to f by uf. U plus f. Okay. So this is magnification in terms of focal length of the lens and object distance. Now from here you can do one numerical. When an object is placed in between optical center and focal length, object distance is given. U is smaller than f. And also in a convex lens, I have just said focus is positive plus f, and whereas u is 1 it is smaller than f, and u is negative also. So now let me use this formula of magnification. M is equal to f divided by u plus f. So therefore m, which is equal to f divided by u plus f. Here let me put all these values with sign. Therefore magnification is positive f divided by negative u, positive f. So this comes a positive number. A positive number smaller than f, because this quantity has been deducted from f. So your magnification comes positive. Here m is equal to positive, and positive magnification means image is your virtual. Therefore virtual image. Number 1, conclusion. Now we need to see that this virtual image is smaller or larger. So here in this equation you can see, in numerator you have f, and in denominator you have a positive number smaller than f. So obviously this ratio is greater than 1, because this denominator is smaller than numerator. So magnification is here is greater than 1. Therefore virtual image is formed, and from this second result you have two results. From second result, the image is magnified. The image is enlarged. So here we find that magnification is your positive number, and u we have taken a negative number. Now in the formula m is equal to v upon u, you get that v is equal to a positive magnification into a negative u. So v comes a negative value, and negative v means image is forming on the same side of the object. So all the informations regarding the image can be obtained. It is forming on the same side of object, plus the image is enlarged as the denominator of this term is smaller than the focus. So you can see that the virtual image forming is enlarged. And why it is virtual? Because magnification has a positive value. It is not a negative value. So all the informations about the image